All right, chapter 6. We're going to wrap up our chemistry. Really, we have 2 weeks left before the end of the year, not school year, end of the year. And then we're going to spend a couple weeks maybe in the lab, and then we're going to transition to physical science. So our last true section in chemistry is going to be talking about solutions. Now, when we talk about solutions, we need to review a couple things. Number one, what are the four phases of matter? The four phases of matter are solid, liquid, gas, and anyone remember the fourth one? Plasma. So solid, liquid, gas, and plasma. Anytime we can have kind of combine these things together, it's possible that we make a solution. So this is review. We've talked about this earlier in the year when we were going over kind of the introduction to chemistry, but all matter can be broken down into two categories. We can either break it down into what we call a substance or what we call a mixture. And a substance is really elements and compounds. So substance is elements and compounds. It's oxygen, it's carbon dioxide, it's all the elements on the periodic table, it's all the compounds we've been talking about in a chemical reaction. Where mixtures consist of two or more substances that are mixed together by physical means, not chemical. So two things that are mixed together by physical means and not chemical. So we just got done talking about chemical reactions. Anytime you have a mixture, you don't have a chemical reaction occurring. It's just by physical means. And we're going to talk about that in section 6.2, kind of what are those physical means which we can get a solution. So two categories, substances and mixtures. Remember that mixtures can be broken down into two categories themselves, heterogeneous and homogeneous. Heterogeneous, mixtures in which the particles are spread unevenly throughout the mixture. Particles will settle out. So examples, a heterogeneous mixture is something that will settle out over time. So think of all the solutions and all the things that maybe even you eat. What are some things that given time will separate out? Right? Well, I gave the example, orange juice with pulp. How about another one? All right, milk. Will milk separate out over time? Yes and no, not really. The milk's going to be a chemical change, but you could argue probably milk is heterogeneous. How about pop? What's going to happen to pop if you leave it out? It's going to get flat, right? That carbon dioxide is going to settle out. Your solution is going to settle out. So pop would be heterogeneous. So heterogeneous solutions or mixtures, anything that will settle out over time. Homogeneous, the exact opposite. Mixtures in which particles are spread evenly throughout, and the particles will not settle out. So example, Kool-Aid, orange juice with no pulp. All right, those are great examples of homogeneous mixtures, something that will not settle out in time. So remember, heterogeneous solutions settle out over time and are unevenly mixed throughout the mixture. Homogeneous are evenly mixed and will never settle out. So the difference between homogeneous and heterogeneous. The last thing that we have to talk about in section 6.1 when we're focused on solutions is some more vocabulary. And we have three pieces of vocabulary. When we talk about solutions, these are kind of the S words other than solution that are going to come up. And the first one is soluble, or what you might see as solubility. Solubility is just the ability to be dissolved. Right? Some things are dissolved easier than others. So the capable of being dissolved is called soluble or solubility, the ability to be dissolved. Some things are not able to be dissolved. So solubility, the capable of being dissolved. Then, when we talk about solutions, we have two things to a solution, the solvent and the solute. What is the difference between the two? The solvent is what does the dissolving. The solute is what's being dissolved. So if we take Kool-Aid, for example, I'm going to make Kool-Aid. Solvent, what does the dissolving in Kool-Aid? Water. Solute, what is being dissolved in Kool-Aid? the sugar packet or the flavor packet. So you have solvent, what does the dissolving, and solute, what is being dissolved. So those are kind of the big ideas in this chapter. Solvent, solutes, and our introduction to solutions. So, this is Mr. Kleinert, and I am signing off.